For the longest time, AI has been kind of locked away inside our computers. But what happens when that intelligence breaks free? What happens when code gets a body and learns to walk, see, and interact with the very same world we live in? Well, that's the incredible idea behind physical AI. And we're about to dive into how it's changing, well, pretty much everything. So, to really wrap our heads around this, let's start with a quick comparison. On one hand, you've got your traditional robots. Just picture a factory arm on an assembly line, right? It follows a super strict, pre-programmed set of rules. It's strong for sure, but it's not smart. But then, on the other hand, you have physical AI. And this is a whole new ballgame. These systems don't just blindly follow rules, they actually learn from their surroundings. They develop adaptive behaviors by interacting with the real world. It's honestly the difference between a puppet on strings and a creature that can actually think for itself. Okay, so how in the world do you build one of these intelligent beings? Well, it turns out it's a lot like building a person. You need three key things. A robot needs senses, it needs muscles, and it absolutely needs a brain to connect it all together. First up, let's talk about the senses. A robot has to be able to perceive the world around it. Now, instead of eyes and ears, it uses sensors. Cameras give it vision, LiDAR uses lasers to paint this incredible 3D map of its surroundings, and touch sensors let it literally feel its way around. This is how the robot pulls in all that raw data about what's going on. But just sensing things is pretty useless if you can't do anything about it, right? That's where actuators come in. Think of these as the robot's muscles. We're talking about the motors that make the wheels spin, the powerful pistons that drive its legs, and the grippers that let it pick things up. Actuators are what give the robot the power to physically change and interact with the world. So what's the piece that connects the senses to the muscles? This is where the real magic happens. It's the computation, the robot's brain. This is the AI model that takes in all that messy, chaotic sensory data, somehow makes sense of it all, and then decides what to do next. It is the absolute heart of the whole system, the decision-making core. All right, so we've got the basic parts, senses, muscles, a brain. But how do they all work together in this continuous, intelligent loop? Well, it all comes down to a really fundamental concept in the world of robotics. It's called the sense, plan, act cycle. It's a simple idea, but it is incredibly powerful. First, the robot senses the world with its cameras and sensors. Then its AI brain takes that info and plans its next move. And finally, it acts on that plan using its motors and grippers. The key thing here is that this isn't a one-and-done deal. It's a constant, lightning-fast feedback loop that lets the robot navigate and react to a world that's always changing. And you know what? This is something you and I do all the time without even thinking about it. Seriously, think about reaching for your coffee. Your eyes sense where it is, your brain instantly plans the path for your arm, and then your muscles act to reach out and grab it. Robots are just now learning to do that exact same thing, just with silicon and steel instead of neurons and bone. Okay, so we have all these amazing individual parts, the sensors, the actuators, the brain. But how do they all talk to each other? I mean, how does a signal from a camera reliably get to the brain, and how does the brain's decision get to the exact right motor? What the robot needs is a nervous system. And in the world of modern robotics, that nervous system is almost always the Robot Operating System, or ROS2. Now, it's not an operating system like Windows or Mac OS. It's more like a flexible open source framework that basically lets all the different specialized parts of a robot communicate with each other. It's the digital glue that holds the entire machine together, and it's built and supported by a huge global community. So let's break down how this nervous system works. Imagine each part of the robot, say the camera or a wheel motor or the gripper, is its own little mini program. In ROS, we call that a node. These nodes talk to each other by sending messages through channels, which we call topics. So the camera node might publish a video feed to the camera topic, and the brain node can subscribe to that very same topic to see what the camera sees. It's this brilliant system that makes it easy to build really complex robots from a bunch of simple, reusable parts. Okay, so we've covered the body, the brain, and now the nervous system. I know this might all sound like something straight out of science fiction, but this is the real technology that is powering the next wave of innovation, like right now. Yeah, this isn't just some theory from a research lab. ROS2 and these core principles of physical AI are the industry standard frameworks being used at the most advanced robotics companies on the planet. I mean, when you see one of those incredible videos of a Boston Dynamics robot navigating a messy construction site, or when you hear about the Tesla bot, you can bet the software architecture underneath it all is built on these exact concepts. And the really mind-blowing part is what happens when we start plugging this physical hardware into the latest and greatest AI breakthroughs. We're now integrating things like large language models and super advanced computer vision to create what are called vision language action models. What that means is we're building robots that can see an apple on a table, understand a command like, hey, can you pick up that apple for me? And then figure out how to actually do it, all on its own. Which brings us right back to our core idea. Physical AI is this monumental shift of intelligence from a purely digital world into a physical one. It's about giving our algorithms the ability to not just crunch data, but to actually interact with, manipulate, and navigate the very same physical reality that we all share. Look, this is not science fiction anymore. The age of physical AI is officially here. And as we give our creations the power to walk among us, the biggest question is no longer can we do it? The real question now is what will we do with it? That's the challenge and the incredible opportunity that lies right in front of us.